Hey guys, for calculus, this is coming from 2.2. And for pre-cal, in the calculus chapter we learned at the end of the year, this is coming from 2.3. This is called derivative rules. So this is going to be a nice change of pace. These rules that you're gonna learn are gonna serve as a shortcut to that lengthy process of the limit definition of a derivative that you did in the last lesson or two. Okay? So the first rule is the constant rule. This rule states that the derivative of any constant is just zero. It's actually that simple, guys. So if your function is a number, a constant, then the derivative of that is zero. Okay? So for example, and yes, it is this easy, the derivative of 17 is just, 17 is a number, so it's 0. The derivative of 3 is a number, is also just 0. Believe it or not, one that trips people up all the time is the derivative of pi. It looks like a symbol, so a lot of people mix it up with a variable. But remember, pi represents 3.14 and so on. Okay, so this is a constant. This is a number, so the derivative of pi is also 0. All right, easiest rule in the book. Next one is power rule. Power rule is whenever I have a term that has a variable in it. So, for example, let's say I have a number times a variable raised to some exponent. The power rule states that you're first going to multiply that exponent to the coefficient. So you're first going to grab that n and multiply it to the front with the coefficient. Then you're going to subtract 1 from that exponent, okay? So, for example, first I'm going to multiply this 2 to the front, and I'm going to say 2 times 5. And then I'm going to say x raised to 2 minus 1. And obviously, as you go doing these, you're not going to have to take this short step here. So 2 times 5 is 10. And then 2 minus 1 is 1, so I don't have to write it. And that's my answer. Okay, let's check out this next one. I'm going to multiply the 3 to the front. So I have 3 times pi x raised to, and then I subtract 1 from the exponent. So my answer looks like 3 pi x squared. Okay, and let's look at the last one. I'm going to multiply that pi to the front. So it's like saying pi times 1 times x raised to, and then I'm going to subtract 1 from pi. Feel free to leave that as pi minus 1. If you start writing something like 2.14, you obviously don't have the ability to write every single decimal in that number, so you'd be rounding it. Okay, so I'd rather you leave it as pi minus 1. All right, let's check out our next rule, sum and difference rule. This rule states that any terms that are separated by addition or subtraction, all you have to do is solve each of them individually. So if I had a function that had 2 different terms, I would just find the derivative of the first and then find the derivative of the second. So for example, I'm going to solve the derivative of x cubed first. I'm going to multiply that 3 to the front. So I'm going to say 3x raised to 3 minus 1, and hopefully you're getting already past that and you can just go straight to writing 3x squared. I'm going to bring down this operation, so I'm going to say minus. Now, the derivative of 4x, technically I have a 1 up here in the exponent, so that is what I'm going to multiply to the front. So I have 4 times 1, x raised to 1 minus 1. So 4 times 1 is just 4. 1 minus 1 is just 0. And remember that any time you have a 0 in the exponent, it changes that to the number 1. So, for example, anytime you have a variable that has a 1, or technically you won't see that 1, that variable will completely disappear. Again, because 1 minus 1 is 0. Anything raised to 0 is 1, and 1 times that 4 just stays being the 4. Okay? And then lastly, I'm going to bring down the addition, right, and do the derivative of 5. 5 is just a number, so the derivative of 5 is just 0. Let me write this out for you, for those of you who need to see it. Okay, so again, this x raised to 0 gave me a 1, and the derivative of 5 gave me 0. So you can clean this answer, and again, you're going to start getting so good at these that you're not going to need to write all of these baby steps. And once I'm done showing you the rules, we'll practice a bunch of these, okay? All right. So you just learned 3 of the main rules. Let's talk about when they start getting a little more complicated, okay? All right, so there's going to be 2 tips here that are really going to help us solve these. We're going to start to see radicals, and we're going to start to see simple fractions, okay? And I call them simple fractions because they are only going to have the variable in either the numerator or the denominator, not both. We'll see fractions that have variables in both in an upcoming lesson, okay? So rewriting anytime you have a radical or one of these simple fractions is going to make doing your derivative a lot easier. So you're going to rewrite and then derive. If you see a radical, you need to change it to a fractional exponent. So this is back from algebra. So if I have either of these two, a root with an exponent, you're going to change it to that exponent over the root. Okay? And we're going to practice a bunch of these now. For fractions, if the variable is only in the denominator, you're going to move it to the numerator with a negative exponent. So for example, if I had a number over x squared, I could put that number times x raised to -2. I am allowed to move a variable, changing its place from numerator to denominator or vice versa, as long as I change the sign of the exponent. Okay? So once you do your rewrite, you're going to do your derivative. If after you do your derivative, you still have some sort of a negative exponent left, you do have to change that back to a positive exponent by bringing it back down to the denominator. Okay? Don't worry so much about the fractional exponents. Like on an AP Cal test, you are allowed to leave it as a fractional exponent or a radical. The only ones that you'll see that they always change back is if it's raised to the 1/2, which is just a square root. But let's check out what those examples look like. All right, let's look at this first one. If this is the question I was given, I want to start off by rewriting it as x raised to 1/3. Okay, notice that I did not write g prime. I have not done the derivative yet. I'm still just rewriting what g of x is. Okay, now that I have it as a fractional exponent, I'm allowed to use power rule. Okay, so now that I'm going to do the actual derivative, I'm going to write g prime of x. So step 1 is to multiply that to the front. So I'm going to say 1/3 times x raised to 1/3 minus 1. Okay? Now, every time that I have a fraction and I'm going to subtract 1, feel free to just subtract it by whatever that denominator is over itself, because I do need a common denominator. So I'm going to change this to 1/3 times x raised to 1/3 minus 3/3. Okay? I can clean that to say 1/3 times x raised to -2/3. And technically I'm done with the power rule, but we remember that we had just written down that you have to leave every answer with a positive exponent. So, and notice in math, whenever you wrote g prime and you keep your equal signs going down without writing anything, it is assumed that this equals is with respect to the last thing you wrote, okay? So now I'm going to change this to 1/3, and I'm going to move this down to the exponent, x raised to 2/3. You do not have to change that back to a radical, so this is one option of your answer. If you did change it, it would look something like this, which is still an acceptable answer. Okay? Either of those two are allowed. All right, for this next one, I have y equals 1 over x squared. So it's a simple fraction because I only have a variable in the denominator. So I'm going to rewrite it as 1 times x to the negative second. Now technically you don't have to write that 1, but just so you see where it went. Now I'm free to do the power rule, so now I'm going to change over to y prime and say negative 2 times 1. And then x, I need to subtract 1, so I need to say negative 2 minus 1. Okay, so I have negative 2x to the negative 3. I finished the power rule, but again, I cannot leave a negative exponent, so this becomes negative 2 over x cubed. And I'm done with that one. Okay. For the next one, again, it's a simple fraction because I only have a variable in the denominator and not in both. It's in the denominator, so I need to rewrite it up to the numerator. Okay. That's what I've been doing here. So I'm going to say 2 times x to the negative first. Now I'm allowed to do power rule, so I have to write my prime. See how as I rewrote y, I kept it underneath with the equal sign, and then once I wrote y prime, kept it underneath with an equal sign. So I have 2 times negative 1, x raised to negative 1 minus 1. And one more clean rewrite here. Negative 2x to the negative second. But I actually have to rewrite one more time because I'm stuck with a negative exponent. So all I have to do is bring that down. Now, I have some students that get confused as to whether to bring just the x down or the 2 down. That exponent only belongs to the x, so it only brings down the x. If it wanted me to bring down both, I would have had to have had parentheses around this entire thing to show that the exponent belonged to the entire thing. Okay. All right, let's check out some more. All right, taking a look at these next three. The first function I have, f of t equals 4t squared over 5. I'm just changing up the variables so you can see different ways they can expose you to these questions. Okay. T is just going to be your variable. That's all that means, that there's a t there. So this is the first time we see a simple fraction where the variable is in the top, in the numerator. So what I'm allowed to do is, because it's in the numerator, I can write it separately next to that 4 over 5. Not put it in the bottom, but I can say 4 over 5 times t squared. Okay? And now I can do a nice simple power rule. And I could say f prime of t equals 4 over 5 times 2 t raised to 2 minus 1. So this is like saying times 2 over 1. Okay? And I just multiply straight across. So 2 times 4 is 8. So I have 8 over 5 times t to the first power. Okay? Because 2 minus 1 was 1. That's why it's to the first power. Let's look at the next one. I have a radical, so I need to change it to a fractional exponent. So I'm going to say 2 times x. A plain radical has a 1 as an exponent and a 2 as the index, so it's raised to the 1/2. Y prime would be saying 2 times 1/2 x raised to 1/2. Now remember, you can write minus 1 and then get common denominator, or you can go straight to the conclusion that your common denominator is going to be 2. So I could say minus 2 over 2. Okay? So 2 times 1/2 is just 1. X raised to, I have a negative 1/2. Okay? Which I can't leave a negative exponent, so I'm going to say 1 over x to the 1/2, or I could say 1 over square root of x. Either of these are perfectly fine. For this next question, we have two problems going on here. we have a radical with an exponent. So we're going to change that to a fraction first, and then we're going to bring it up so that it's no longer in the denominator. We can also treat these coefficients 1 over 2 up front. So we can say 1 over 2. I'm going to start off by changing this to an x raised to 2 over 3. Okay? The next thing I'm going to do is I'm going to move this up to have a negative exponent. So I'm going to say x raised to negative 2 over 3 over 2. All right? I'm doing things one at a time, but once you feel confident with this, you can do them all at the same time, okay? Now, this being divided by 2, we said is the same as saying 1 over 2 x to the negative 2 over 3. So, I changed my radical to a fractional exponent. I moved it up with a negative exponent, and now I took my coefficients out as a 1/2. So now this should feel like a much easier power rule, okay? So I'm going to say 1/2 times a negative 2 over 3, right? I multiplied it to the front. And now I'm going to say x raised to negative 2 over 3, and if I need to subtract it by 1, I'm really subtracting by 3 over 3, okay? So now you can see that these 2's cancel out, okay? And I'm going to be left with negative 1/3 x, and if I'm going to keep the common denominator of 3, and then I'm going to subtract negative 2 and negative 3, which make a negative 5, okay? Which, remember, in Cal, they always want you to leave the exponents positive. So that means I'm going to move it up. I'm sorry, move it down. It's already up. So we're going to write that as negative 1 over 3 x raised to 5 over 3. Okay? And we can leave it just like that. All right, let's take a look at our next one. I'm going to start off by rewriting it first. I apologize. I made a little mistake here. Here, I rewrote. Here, I rewrote. And here, I rewrote. Here, I already started doing the derivative. So hopefully you caught that I should have done something here. I should have changed my notation to saying instead of y, y prime. And now all of these equal y prime. My apologies for that. So here I'm going to start off by rewriting. I'm going to change this to say negative 1/2 times x to the 4th. And then rewrite the rest so that I can do power rule. Now that I'm going to start my derivative, I'm going to write g prime of x equals, I'm going to multiply the 4 to the front, and then I'm going to subtract 1 from the 4. Plus, now I'm going to multiply the 3 to the front, and I'm going to subtract 1 from the 3. And here, technically, my exponent is a 1, so I'm going to say 2 times 1 x, and then 1 minus 1 in the exponent. Okay? So you're going to see here, when I multiply 4 over 2, is going to give me 2, and then I have that negative there. Negative 2x to the 3rd, plus 3 times 3 is 9. X to the 2nd power, 3 minus 2, minus 2 times 1 is 2, and then 1 minus 1 is 0. Anything raised to 0 is just 1, so that will cancel out. Okay? And here is my answer for this one. All right, let's take a look at this last one. Okay? You haven't learned rules for division yet. But remember that when you're dividing, each one of these terms get divided by this x. So I can rewrite this as 3x squared over x minus x divided by x plus 1 over x. Okay? Now at this point I can reduce each of them. This has an x squared on the top and an x to the first and the bottom. So remember, when we are dividing, we subtract the exponents. So I'll have 3 times x to the first power minus anything over itself. X over x is 1 plus, and then I'm going to move this x up with that negative exponent. Okay? So now that I'm starting the derivative of 3x is just 3. Okay, remember the 1 gets multiplied to the front and you subtract. Okay, now anytime that happens, we saw it happen here, that x is to the first power, the derivative will just be the coefficient up front. Okay, derivative of negative 1 or of 1 is 0. Any constant is 0. And then here I'm going to multiply that negative 1 to the front and then subtract 1 from the exponent, which will take me down to negative 2. Okay, we don't have to worry about this minus 0. 3 minus 0 is just 3. And then we have minus 1. I'm going to take this x to the negative second. I'm going to bring it down and call it x squared. And you are done there. Before we continue, my calculus class is going to notice that the next section in your homework for 2.2 has some trig functions. Pre-cal, you guys won't see that until 2.5. So my calculus class, I am going to do a separate video just on all trig functions. Make sure to take a moment and watch that. All right, let's talk about how you're going to start to see some of these operations happening in context of a word problem, okay? And in AP, this is very, very popular, especially in your FRQs, your free response questions. The AP test is highly conceptual. It means they just won't ask you for a basic derivative. They'll ask for you in the terms of these words, okay? So velocity is one of the most popular ways to talk about a derivative. So if I give you a function, that function, original function, represents the position of some object that could be in motion, okay? And plugging something into f of x will tell you where its position is, where it's located. When I do the first derivative, okay, remember slope, rate of change, I'm telling you about the velocity, okay? And then second derivative, which we'll start to see more in upcoming lessons, we won't do it so much now, we'll see the acceleration of an object in motion, okay? If they ever ask you for the speed of an object, that is the absolute value of velocity, meaning they don't care what direction it was going, they just care how fast it was going. And then average velocity, remember we said that word average just means to go straight to slope, okay? So now, if they ever ask you as to when velocity is positive, if they ever want you to solve for when velocity is positive, meaning the first derivative being greater than 0, they'll ask you by saying, when is the object moving to the right or upward, okay? If they want you to solve for velocity being negative, meaning the first derivative less than 0, they will ask you, when is the object moving to the left, okay, or downward. And then if they ever want you to solve for velocity equal to 0, meaning the first derivative equals 0, they'll put the wording down of the object having stopped, okay, or being at rest. So let's see what some of these questions will look like. The first example says, a billiard ball is dropped with its position being represented by s of t equaling negative 16 t squared plus 100, where s of t is measured in feet and t in seconds. Find the average velocity between 1 and 2. So the word between lets me know that this is an interval, and they're talking about between 1 and 2 seconds, okay? So the key word here was average velocity. This is what lets me know I'm going to do slope. And I can say average velocity equals my function at my second, right, f of b, minus my function at my first time, a, slope is y2 minus y1, over b minus a. My x is subtracted. Okay? So feel free to use your calculator on this next part. If I plug 2 into this function right here, okay, I'm going to get 36. Minus, if I plug 1 into the function, I'm going to get 84. Over 2 minus 1 is 1. And when I subtract those two, I get negative 48. And then we must remember our units. Velocity always has 2 units. It has its distance with respect to its time. So this was going feet per seconds. Okay. Now, sometimes in an AP test, actually pretty often, they ask for you to explain or interpret the meaning of that answer. And basically what you just found is that the ball was being dropped at an average rate or average velocity of, you could either say negative 48 feet per second, but the fact that you said dropped already indicates its direction, the fact that it was going in a negative direction. Okay, remember we said negative, velocity being negative means left or down. So the moment you say the word dropped, you are technically already saying the negative. So you can say the ball was dropped, and that right there is you stating your negative, okay? If it came out positive, you would have said it would have been thrown upward, okay? Now this is average velocity, so you have to indicate that word average. An average velocity of 48 feet per second. Okay. For this next question, it says a diver jumps off a diving board with his position being x of t equals negative 16t squared plus 16t plus 32. Where x of t is measured in feet and t in seconds. First question says, when does the diver hit the water? And the second says, what is his velocity on impact? So let's call the first one part A. And when it says, when does the diver hit the water, that means that his position comes back to the ground, so his position is back at 0. If you're thinking of it like a drawing, he jumps off the diving board and then goes into the water. So his y value, his position, is 0. And then they told us that this equation represents his position. So I can say negative 16t squared plus 16t plus 32 equals 0. And now I'm just solving for t. Okay? So I can factor out a negative 16 from all three of them to make this problem a little easier. I can divide this negative 16 over, and then 0 divided by anything is still 0. And now I can have two binomials t times t equals t squared, and 1 times 2 equals 2. I need to end up with a negative t here, so I need my larger number to carry that sign. And I could say that t equals negative 1 and 2. Now, because this is a real life scenario and they said time starts at 0, I can't go back in time. We can't time travel like that. So I'm not going to use negative 1 as my time. I'm going to be using 2. Okay, so my answer here is that he hit the water. He went into the water 2 seconds later. So the next part of this question says, what is his velocity on impact? So impact means that he has stopped moving. okay? And we had written a little while ago that velocity being set equal to 0 represents someone or an object not moving. So for part B, because it says velocity on impact, that means they want to know when velocity equals 0. We also said the velocity is the first derivative. So I need to set, oh, let me white that out, sorry. The first derivative of x of t, so x prime of t, equals, remember I'm going to multiply the 2 to the front, so negative 16 times 2, I have negative 32t to the first power because I subtract 1, plus, remember when I just have a variable and a coefficient, I'll just end up with that coefficient because it's like multiplying the 1 to the front and subtracting that 1, which leaves me with no exponent. And then plus derivative of a constant is 0, so I can stop right there. So that's going to tell me the velocity, but they specifically, I'm sorry, I put velocity equals 0. I apologize. It says on impact. So impact, we found over here, happened when time was 2. I apologize for that mistake there. So again, velocity on impact. In this first part, we found that he hit the water at 2. So on that impact, what was his velocity? I'm going to find x prime at 2. So just plug in that 2. Okay, and you should end up with negative 48. And then velocity has my distance per time. Okay, remember that this means he was going downward. So when he hit the water, when he splashed in, this was his velocity. Okay,